Hello again. So, this is another question of the AC circuit analysis, and here again we have to find the similar quantities which we have previously found, but what is the circuit here? That is the circuit which we have to analyze by using the previously established methods. Okay. So, what are basically the tasks here? So, in first part of this question we have to find the total impedance ZT in polar form. Okay. So, again let me start it with this Z of t, okay, and the similar method here that we have to write the values of the all the resistors which are available. So, only one resistor is available and that is this R. So, writing this R, okay, then after it we have to write the values of all the reactive elements. Okay. So, here in this question we have two reactive elements, and what are those elements? Let me take a look here. This one is the inductor while this one is the capacitor. So, that is a very conventional RLC circuit. Okay. So, we have to write the values of XL and XC here, and we have previously seen that in order to write the value of X of C we have to put the value of plus J with it, while with X of C I have to write the value of minus J. Okay. So, writing them here as a imaginary components, okay, and now writing here J X of L, okay, and similarly X of C. Now, putting their values, what I will get? Z of t is equal to the value of R is 4, okay, the value of R is 4, the value of X of L is 6. So, this is J 6, while the value of X of C is 10. So, that would be minus 10. Okay. Now, calculating them, what I will get? Z of t is equal to 4 plus J 6 minus 10. Okay. So, ultimately we will get Z of t is equal to the 4 plus J minus 4, or it will be Z of t is equal to 4 minus J of 4. Okay. So, that is basically the Z of t. In order to write them in the polar form, because now this one is the rectangular form. So, writing it in polar form, Z of t will be equal to the magnitude it has. So, again coming over here and writing 4 minus 4, and with this iota here, okay, it would be this one. Now, converting it into the polar form, this is the third one, and now it will be 4 square root of 2 and minus 45, or it will be 5.65, or it can be 5.7, and the angle is minus 45 degrees. So, 5.7 ohm, and the angle it has is the minus 45 degrees. Okay. So, that is the impedance in polar form for this RLC circuit. What is part B of this question? We have to draw the impedance diagram. In order to draw the impedance diagram here, this is basically the capacitive type circuit here. So, drawing the impedance diagram here, what I will get? This is basically the axis. Okay. This is the axis here, and the total impedance which we have got here. Let me draw each of the impedance here separately. So, using blue color for it. So, for the resistor I have this impedance which is 4 ohm. Okay. For the this is R equal to 4. Okay. Similarly, for the inductor we have this X of L equal to 6 ohm, and for the capacitor which has this resistance is 10 ohm, or I can write it this one. Okay. Because now it has minus J with it, we can write it like this one here. So, this is the real axis, this one is the imaginary axis. Okay. So, taking the cumulative of all these, we have got this one. So, with it the angle is minus 45 degrees. So, from this positive x axis we have to go clockwise direction. Okay. So, in clockwise direction we will have this angle which is now 45 degrees, and the amplitude of this resultant will be 5.7 ohm. Okay, so that is what this is the impedance diagram of this circuit. Now proceeding to the other parts, find the value of C in the microfarads and L in henries. Okay, so we have to find the values of the capacitance and the inductance here as well. Okay, so now to find the values here, this is part C. So first of all, starting from x of L, we know that the value of x of L is omega L. Okay, and ultimately x of L, if we put the value of omega, so x of L is 2 pi f L. Okay, so what is the value of this omega? If we know the value of omega, or if we know the value of 2 pi f, we can very easily find the value of L. So here in coming towards the source here, we can very easily see that this is sine of omega t. Okay, so this is the peak value. So generalized form of this is sine of omega t. Okay, while comparing these two equations, we will get that omega here is 377 radians per second. Okay, so now we know that the value of omega is known, so this one xl is also known, so we can very easily find the value of L from it, which is xl divided by omega. Okay, the value of xl is how much? That is 6, and the value of omega is how much? That is 377. Now calculating it, what we will get? 6 divided by 377, sorry, this one. So now this is 15.9 millihenry, because now this is 0.015. so writing it in the scientific notation, it will be 59.9 millihenry. So this would be 59.9 millihenry. Okay, so that is the value of the inductance here. And we have seen that this is in henries. So if we want to write it in henries, what was that? This was 0.0159. so in henries this was 0.0159 henries. Okay, so that is the value of L. Similarly, in order to find the value of C, we know that x of C is 1 over omega C, or the value of C is 1 over omega x of C. Okay, putting their values here, omega is 377 and the value of x is 10. Okay, so this would be 1 over 3770. So now finding their values, 1 over 3770, so this would be this one. So it is now 2.65 into 10 to the power minus 4, 2.65 into 10 to the power minus 4 farad. Okay, so this is in farad, but here in the question what we are given, that we have to find the values in microfarads. So in order to write the values in microfarads, let me 2.65 into 10 to the power minus 4. So in microfarad we have to make it minus 6, so multiplying it with minus 2 and also with plus 2 as well. Okay, so now this is in farad. Now calculating them, and we will get that C will be equal to 2.65 multiplied by this 10 to the power 2, rearranging it, 2.65 into 10 to the power 2, and here the bases are same, so exponents will be added together. So minus 2 minus 4 and farad, or multiplying 2.65 with this 10 to the power 2, which is 100. So C will be equal to the 265, and here it will be 10 to the power minus 6 farad. Ultimately it will be C is equal to 265, this is 265 and 10 power minus 6 is equivalent to the micro. So, that would be 265 microfarad. Okay. So, two values are known here which are the inductance and capacitance values, okay, and we have calculated them very easily from the information which is available in this question. In part D of our question, we have to find the current and the voltages VR, VL and VC in phasor forms. So, again let me start it from here. We have to find the value of VR, we have to find out the value of VL and we have to find out the value of VC. Okay. So, these three values we have to find out. So, initially in order to find out, we know that this should be IR, this should be I into JXL or it would be I into minus JXC. Okay. But we do not know the value of I. So, initially first of all we have to find the value of I here. So, I here will be total current will be equal to the voltage divided by the total impedance. Okay. But here we do not know the value of E. We have just the expression of E, but we do not know the values in the phasor form, because now this one is the peak value. We can see that this one is what? This is the peak value, this is omega and the angle it has is basically 0 degrees. So, this Vp should be converted into the Vrms and we know that Vrms is equal to the Vp divided by square root of 2. Okay. So, now let me calculate them here. So, first of all let me calculate the value of in phasor form. So, here it will be Vp divided by square root of 2 and the angle it has is basically 0 degrees. Okay. Vp is how much? 70.7. Let me confirm it here. Yes, that is 70.7 volts. So, here it would be 70.7 divided by square root of 2 and the angle it has is 0 degrees. Now, calculating them again here, 70.7 divided by square root of 2 and it would be 49.99 or almost 50. So, this is now 50 volts and angle it has is 0 degrees. Now, putting these values here, so E is now calculated and that is 50 and the angle it has is 0 degrees, while the value of Z of t which is earlier calculated and that Z of t is 5.7 ohm with the angle of minus 45 degrees, 5.7 and the angle of minus 45 degrees. Now, calculating them, 50 divided by 5.7 and the angles are 0 degrees. It will be here in the denominator and it will become positive here, and calculating them, 50 divided by 5.7, 50 divided by 5.7, this one is now 8.77 amperes with the angle of 45 degrees. Okay. So, that is now the current which we have. Now, taking this value and putting the value here, the value of current is 8.77 with the angle of 45 degrees, while the value of resistance here is 4 ohm. Okay. So, that is basically the 0 degrees. So, now multiplying it with 4 multiplied by 8.77. So, multiply it with 4, it will be 35 volts and the angle it has is 45 plus 0 degrees, because both the terms are multiplying together. So, their angles will be added together. This point is cleared in our phasors video. So, if you want to look at that how these two terms are added together, you have to go back to the phasor video and the link of it I will share over here. Okay. So, that would be 35 and the angle of 45 degrees. This is in volts. So this is for V of R. Now in order to calculate the value of V of L, I have to write the value here as well, the current and the angle 45 degrees. Now Jx of L, J is 90 degrees, while the value of X of L is how much? The value of X of L is 6. So this is 6 and the angle is 90 degrees. Okay. So now 8.77 multiplied by 6 is 8.77 multiplied by 6 is 52.62 volts, while the angle it has is 90 plus 45 degrees. So it would be 135 degrees. So this is the V of L, and now the value of V of C is 8.77, angle again 45 degrees multiplied by the value of J minus Jx of C, converting them into the polar form. It would be a magnitude of it will be 10, and the phase angle it has will be minus 90 degrees. Multiplying them together, I will get 10 multiplied by 8.77. So it would be 87.7 degrees, and adding them together, I will get minus 90 degrees and plus 45 degrees. I will get here minus 45 degrees. Okay. So that is again in volts. So this is for the V of C. So we have calculated the values of V of R, V of L and V of C, which are mentioned here. Okay. Now going forward here, we have to find the and draw the phasor diagram of the voltages E, VR, VL and V of C and current I. So as we have found their values, it is not very difficult for us to draw them here. So this is which part is this? This is the E part. So we have to draw the phasor diagrams. So what we have to draw? We have to draw I, E, V of R, V of L and V of C. Okay. Now representing them with different colors. Let me represent I with this red color, this total E with this blue color, while the other voltages, let me this VL and VC with this green color, while again this V of R with let me use this color. Okay, this color. So now let me draw them here. Let me use this one here for the phasor diagram. Okay, so let me first draw the value of E, and that is 50 volts and with the phase angle of 0. Okay. This is E, and E is how much? 50 and 0 degrees. So after plotting the phasor diagram of the total voltage here, let me here plot the value of the current. So the value of the current which we have found here is 8.77 amperes with the phase angle of 45 degrees. So let me calculate it here and see that we have actually calculated it, and let me plot it here. So angle here is plus 45 degrees, so this is 45 degrees. Okay, this is what, this is the current, and the value of current is 8.77 amperes. Okay, so this one is the value of the current. Okay, so after it, let me plot the value of V of R. Let me plot it with this color because I have represented it here. So using this, the value of VR is how much? Let me see here. That is 35 with the angle of 45 degrees. So this is in phase with this current. So here, and the magnitude here is 35. Okay, so 35 is larger than this one, so let me, this one is the V of R. Okay, so and the angle it has is again 45 degrees. Okay, so this is the value of V of R. After it, let me plot, or let me draw the values of V of L and V of C and represent them with this green color. So the value of V of L here is how much? That is 52.62 with the angle of 135 degrees. So this is 90 and 135 almost lie here. Okay, so this is the 135 degrees. Okay, and the magnitude it has is here. This is V of L, and this is 52.62. Okay, so this is the value. Similarly, the value of V of C is, the value of VC is 87.7 and the angle of minus 45 degrees. So again this one, and minus 45 degrees is basically the clockwise angle, and we will start it from here, this positive axis, and clockwise angle will lie here. This will be the angle of 45 degrees. Okay, and this is what? This is V of C. Okay, so that is the phasor diagram which we had to plot in our part E of this question, and we have seen different quantities here which lie here in this diagram, and from this we can very easily see the phase angles associated and magnitudes of different quantities which we have previously calculated. After it, there is part F of this question, and we have to verify Kirchhoff's voltage law around the closed loop. So this is the closed loop, and around it we have to verify the Kirchhoff's voltage law. So in order to verify it, we have to see that this is F. We have to see that whether the total voltage here E is equal to the phasor sum of the this is V of L and V of C. So phasor sum of all the voltages is equal to the total voltages or not. Okay, so in order to do it, let me start it from the left hand side first. So we know that the left hand side we have the voltage here, and that is 50 volts and 0 degrees, and we can also confirm it from here as well, that the total voltage here in the phasor form or in the polar form here we have is this one. Now going toward the right hand side here, we have to see that whether the summation of VR, VL and VC is equal to the total voltage or not. So now writing their values here, the value of V of R is how much? 35.45 degrees, 45 degrees. Okay, the value of VL is how much? That is 52.62 and 135 degrees, and the angle is 135 degrees, and value of V of C is how much? That is 87.7 and angle is minus 45 degrees, 87.7 with this minus 45 degrees. Now in order to solve it manually, what we can do here, that these are all the quantities which are in the polar form, and we have seen in our phasor videos that in order to add the phasors, it is convenient for us to convert them into the rectangular form first, then we have to add all the real quantities and the imaginary quantities, and after calculating the resultant of all the values in the rectangular form, we have to convert back them into the phasor form. Okay, so that is a feasible method if you are doing it manually. Okay, but we have here is the calculator, and in order to solve them here, let me use the values here. So that is 35, and the angle it is 45 degrees plus 52.62, and the angle is 135 and 87.7 with the angle of minus 45. Okay, so that is the summation. Let me add them and we will get the answer in rectangular form. Okay, so you can see that this is in rectangular form. In order to convert it into polar form by using calculator, using this one, now 3, and here we will see that this is 49.55, which is almost equal to 50, and the angle it has is almost 0 degrees. This is 0.0 something, which is almost equal to the 0 here. So now writing values here, and we can see that this is almost 50 volt, and the angle it has is 0 degrees, which is almost equal to the value of E. So it says that the right hand side is equal to the left hand side. Okay, so which satisfies the Kirchhoff's voltage law. Okay, so that is a proof of the KVL, that the phasor sum of all the voltages in this loop is equal to the total voltage which we have here. Okay, so that is the solution of part F here. In part G, we have to find the average power delivered to the circuit. The same method which we have previously seen, that by using it we can write here IE and the angle between them, which is cos of theta. This cos of theta is the power factor, which is cos of theta, or we can also do it by using R by Z of t. We have done it previously. Similarly, in part D, find the power factor of the circuit, which is this one. By finding the average power, we have also have to calculate the value of the average power and indicate whether it is leading or lagging. Okay, so that is a very important thing here which we have to see here. So here in the diagram or in the impedance here, we can very easily see here and here and here, see that this is now the circuit of the capacitive nature, because the capacitive reactance is dominant here due to the availability of this negative sign with the imaginary term here, and also this negative angle. So that is the capacitive nature, in which current leads and voltage lags. So when current leads, so therefore power factor is also leading here. Okay, so for this part we have to find the power factor, which is from the cos of theta, where theta is the angle between E and I, or we have to find the ratio between the resistor and the total impedance here, and we have to use their magnitudes here, and we will see that power factor is known, and after it, to see whether it is leading or lagging, we have to see that whether the circuit is capacitive or reactive or inductive. So as the circuit here is of capacitive nature, so the power factor will be leading here. Okay, after it, we have to find the sinusoidal expression for the voltages and currents. We know all the voltages here which are now in these forms. Okay, these are basically the average voltages or the RMS voltages. So in order to find the, let me use the VR, and in order to find it in the sinusoidal form, what we have to do, we have to write VP sine of omega t plus theta. Okay, do we know the value of theta in voltage here, yes, we know the value of the voltage here, and that is the total voltage or the RMS value here is 3545 degrees. So let me see that. So V of R with us is 35 volts and 45 degrees. From it we can see that the peak value here is the 35 multiplied by the square root of 2. Why? Because the RMS value is always equal to the VP divided by square root of 2. So now in order to find the value of V of P, we have to multiply this square root of 2 with the RMS value. Okay, so this RMS value is given here, which is this 45 degrees, which is also mentioned here. Okay, so we have to find this value and then put it here. Also the value of theta is also given, and this is here. Okay, so now let me use this red color. So this is now the value. Okay, and we have to put it here. Okay, similarly the value of theta is 45, we have to put it here, and ultimately what we will get, the value of VR will be equal to the 35 multiplied by square root of 2 . This is 49.5, so it will be 49.5 into sine of omega t. Do we know the value of omega? Yes, we also know the value of omega, and that is 377. Okay, so writing the value of omega here as well. So 377 t, and the angle it has is 45 degrees. So this is the expression for V of R. Similar method we can use for other quantities, just like V of L, just like V of C, where the angles and the RMS values and angles are also given. In order to find the value of the peak value from this RMS value, what we have to do, we can use this formula. Okay, and from it we can also use this formula as well, while theta would also be here, and theta will be given similarly for this one as well. So that is the solution of our I, and from it we can also plot the values of all the waveforms in the time domain. Okay, which we have covered in our previous videos as well. So that's it for today, in which we have discussed this RLC circuit, and we have calculated all the required values by using the methods which are mentioned in our book. So thank you so much. Take a look over all the steps here and grasp the conceptual overview of these type of circuits. Thank you so much, and I will see you with some more examples, more questions in our upcoming video.